Hello and welcome to my video where I'm going to talk about mechanical energy. So mechanical energy is a combination of potential and kinetic energy. And so if you haven't yet, watch the last two videos where I talk about those, because those are important before you can start this topic. So mechanical energy is the combination, and oftentimes we're talking about transferring back and forth between mechanical energy and potential, or like potential and kinetic, going back and forth between those, or perhaps talking about the beginning and the end of a given situation. So we can talk about the beginning mechanical energy being equal to the final mechanical energy if you're comparing the beginning and the end of a given situation. So it's helpful to remember that mechanical energy is a combination of both. There's just different ways of writing it. But mostly, generally speaking, this last way is the method that I would like you to write it, because it actually gives you the full experience, the full equation. So just a reminder that this first part is potential, the second part is kinetic. Okay, so with that in mind, let's take a look at the couple equations down here. Okay, a very silly archer decided to see how high he can shoot an arrow. If the arrow leaves the bow moving at 68.9 meters per second, shooting straight up, how high will it reach? I believe that I tried to find actual real-life data for all these questions, so I believe that this is like a real speed of shooting an arrow. So anyways, that's really fast. That's really fast. But anyways, the arrow leaves the bow at that speed, shooting straight up. How high will it reach? Well, if you aren't sure how to start this, always start by drawing a diagram. So there's the bow down here. It's got an arrow. You're shooting it straight up, right? It goes up to a point, and then it comes back down. Right? And so you can imagine that at the top of our shot, right up here at the blue marker, the velocity is 0. Right? And you can also imagine that at the beginning, down here, the height is 0. Okay? So I like to write this out as the full equation and then cancel out what doesn't matter. Okay, so mgh1 plus mv1 squared divided by 2 equals mgh2 plus mv2 squared divided by 2. So what am I doing here? Well, why am I putting a 1 and a 2? Well, it's the two parts of our situation, so two different points in time. Okay, and it's helpful to note that this is the first part, this is the second part. Okay, well, do we have more information about the first part? Oh yeah, we certainly do. We have V1 is, right when it leaves the bow, it's going 68.9 meters per second, and we're trying to look for the H2. So that's our unknown. So we need to just have 3 of those 4 numbers, and we can solve for our answer. Now, given the fact that H1 is 0, that will cancel that whole part. Given the fact that V2 is 0, that will cancel this whole part. Because if it's 0, then multiplying times m, multiplying divide by 2 or times 2 or whatever, it all ends up still being 0. Okay, the next thing to note is that if there's m on both sides, we can actually divide by m on both sides, and those will also cancel. So all that said and done, really all that we're left with is v1 squared divided by 2 equals gh2. That's it. That's it. And we're solving for h2. I guess another important thing to say is that we should know that gravity, g, is 9.8 3.81 meters per second squared. We should know that. It also says it in our formula sheet. Okay, so we're solving for H2. So what we're going to do is make sure we're trying to get it by itself. So we're going to divide by G on both sides. That's going to cancel there. And so we're left with V1 squared divided by 2G equals H2. And now we can just write in our values for V1 and for G. So V1 is 68.9 meters per second squared, and times divided by 2G, which is 9.81 meters per second squared. And so that whole thing is going to equal, I just have to plug it in my calculator, 68.9 squared divided by 2 times 9.81. And that whole thing is 241, but sig digs, so 42 meters. Right? That's going to be, yeah, 3 sig digs. All right. So hopefully that made a little bit of sense. Try pausing at this point, trying the next 2 questions, and then press play and see if you get the same answers. All right, so let's take a look here. The Mindbender roller coaster at Westhampton Mall has a maximum height of 44 meters. So you can imagine that we have a roller coaster like this, and the maximum height that it ever reaches is 44 meters. Okay, I guess one thing the question doesn't say is that you kind of have to assume that V is 0 at that point, or V1 is 0 at that point. Okay, but we can say our H1 is 44 meters. Assuming 0 friction, what is the maximum velocity of the ride? So assuming that it's not slowing down at any point due to friction, when H2 is 0 would be the maximum possible velocity. So we're looking for V2 in this case. Okay, and we can simplify this. We don't have to write M, right? M shows up everywhere, every time. So we don't actually have to write M. So we're going to not write M, and we're going to just write the rest of it. So now that we know that we can actually just divide by M everywhere, you don't have to write M. If it helps you, write it. If it doesn't, don't. So it's up to you how you want to do that. So I'm going to not write it this time just to show you guys how it could look if we just divided by M everywhere. And as long as you do it to both sides of the equal sign, you're allowed to do it. The problem is if you don't do it to both sides. Okay. Now let's take a look at our zeros. So V1 is 0, so that's going to cancel here. And H2 is 0, so that's going to cancel here. So now let's see what else we can do once we write this out. So G H1 equals V2 squared divided by 2. And we are trying to find V2. So again, if it wasn't 100% clear before, we're looking for the V2. That's why there's a question mark there. We're looking for the maximum velocity. If the height is 0, that would be the maximum velocity. So anyways, let's move stuff over. So if we multiply by 2 on both sides, it lets us cancel. So let's rewrite that out. 2G H1 V2 squared. Now we have a little squared there, and that's no good. We want to get rid of that, so we need to square root on both sides. Square root lets us cancel with the squared. So now we're left with square root of 2G H1 equals V2. All right, very good. Now all we have to do is plug in our numbers. It's super important that we do it like this, because if you're not doing it this way, you're likely to have sig dig errors. some rounding errors. So if you are solving it the way I'm doing it, algebraically first, then you're less likely to have significant digit errors. So anyways, plugging in our values, 44 is our height, and plugging it into our calculator, so square root of 2 times 9.81 times 44 equals 29, and yeah, just 2 sig digs, so we're going to leave it there. So 29 meters per second. I wonder if this is correct based off of the real numbers from Mindbender. But they do have friction, and they also possibly do have a v starting velocity. So it's not going to be exactly right, but I wonder if it's close. All right, next 2 questions. Skateboarder drops in on a half pipe that is 3 meters tall, halfway up the other side. How fast is she moving? So again, I like to draw the situation. Half pipe is like this. There's the skateboarder. Amazing. Starting off with V1 is 0. And finally, at the end, H2 is 0. Oh, halfway up the other side. H2 is not 0, it's 1.5. And we know the initial height is 3.0. So H1 is 3 meters. Okay, so halfway up the other side, so that's 1.5, that's half of 3.0. Okay, which means that we are going to be able to put it into our basic equation again. Just taking out the mass ahead of time because it's a little bit faster. Okay, so the only thing that's 0 is the original speed, so we can cancel that out right away. Okay, and now we can just rewrite it out. GH1 equals GH2 plus V squared, V2 squared divided by 2. We're going to move the GH2 over to the other side, so we're going to subtract by that on both sides. So if you subtract and add by the same number, they're going to cancel. So now we're going to have GH1 minus GH2 equals V2 squared divided by 2. Whoops. So now what we need to do is move the 2 over. So we're going to multiply by 2 here and multiply by 2 here. The 2's are going to cancel there. And so now we can put it like this. Or, yeah, I'm going to write it like this. So it makes it abundantly clear what's happening. There are nicer ways of writing this, and maybe I'll show that to you in a second. But for now, this is what we're doing. And then we have to get rid of the squared, so we're going to square root on both sides. That's going to cancel out with our squared. And so we're going to be left with V2. Whoops. V2 is the square root of 2g h1 minus 2g h2. And if this is clear to you, awesome, do this. I'm going to factor out a 2g on both sides. If it's not clear, ignore what I'm doing right now. But anyways, either way, those two are the same. So now you just need to plug it in your calculator. So 2 times 9.81. H1 is 3. Let's just leave it as 3. And then H2 is 1.5. And so this whole thing is going to equal is 5.4 meters per second. We're rounding it there because of the 2 decimal or 2 sig dig significant digits there. Okay, so 5.4 meters per second. Okay, let's look at the next question. And this one's a challenging one here as well, because we're not looking for height, we're not looking for speed, we're looking for gravity, which is kind of funny, kind of interesting. Okay, so let's just take a look at these, at the different measurements here. So first of all, it says grandfather clock uses a gigantic pendulum to keep track of time. And so it swings back and forth and back and forth. So you can imagine that this is the weight. It goes this way into this position, then it goes back up into this position, and then back down, back up, back down, back up, back down, back up, etc. Right? Back and forth. And so when it's at this point, its height is actually the maximum. Okay? And so that is told to us is 20 centimeters, or we need to have that in meters, so 0.2 meters. And velocity is 0, because it's at its maximum height. And the bottom, the height is 0. Okay, and the speed is told to us is 2, well, we don't need the decimals there, but 2 meters per second. Okay, it's asking us to find gravity. Okay, so this is the unknown. Okay, and it tells us that the mass is 2 kilograms, but we know that we don't even care about that because of our equation allowing us to divide by mass on all sides to get rid of it. Alright, so looks like this once we've divided by mass on all sides. And so now what we can do is we can see h1 is 0, so we're going to cancel there. We don't care about that term. v2 is 0, so we're going to cancel there. We don't care about that term. So now we're just simply left with v1 squared divided by 2 equals g h2. And if we're looking for the g, then we're going to divide by h2. And we're going to divide by h2. And so now we're left with v1 squared divided by 2h2 equals g. So now what we can do is v1, we can just plug in our numbers. So v1 is 2 meters per second. We're going to square that. The bottom of our fraction is 2 times the h, which is 0.2 meters. And if you plug all that into your calculator, you get 10 meters per second squared for gravity, which is close to our 9.81 meters per second squared. So within error, that is about right. Like, measurements could be taken wrong, friction, all sorts of stuff. Right? But close enough to our measurement for gravity. Alright, I hope that this video helps you understand mechanical energy a little bit better, and good luck!